Novalis, a German writer from the Romantic era, wasn't just a poet. He was a visionary thinker who saw the interconnectedness of everything. He believed in a universal science that could unite all areas of knowledge, from art and religion to science and mathematics. He began compiling his ideas in a massive work called the Encyclopedia, a project that remained unfinished at his death.
Novalis was particularly drawn to mathematics. He saw it as the purest form of thought, a language capable of expressing the hidden structures of the universe. He believed that by translating concepts from different fields into mathematical terms, we could unlock a deeper understanding of the world and ourselves.
Novalis's vision might seem radical, but it's a vision that resonates deeply with our modern understanding of the cosmos. Today, we use mathematics to explore everything from the smallest subatomic particles to the largest structures in the universe. In a way, Novalis was centuries ahead of his time, anticipating a world where mathematics would become an indispensable tool for understanding reality.
We usually think of translation as moving words from one language to another, but Novalis saw it as something much broader and more profound. For him, translation was about finding the hidden connections between seemingly disparate things. It was about transforming and transposing ideas, taking them from one realm of knowledge and expressing them in the language of another. Imagine trying to explain the feeling of love to someone who's never experienced it. You might use metaphors comparing it to the warmth of the sun or the beauty of a sunset. You're essentially translating an abstract emotion into tangible images and sensations. That's what Novalis wanted to do with mathematics. He saw it as a universal language that could bridge the gap between different disciplines. By translating concepts from art, religion, and philosophy into mathematical terms, he believed we could uncover the underlying unity of all knowledge.
Mathematics is often seen as a cold, impersonal subject, all about numbers and equations. But at its heart, mathematics is a language of patterns and relationships. It's a way of describing how things are connected and how they change over time. And these patterns are everywhere, from the spiral of a seashell to the orbits of planets. Think about a simple equation like 1 + 1 = 2. This isn't just an abstract mathematical truth. It reflects a fundamental principle of how things combine and interact in the real world. When we add one apple to another apple, we get two apples. The equation is a symbolic representation of this physical reality. Novalis recognized the power of mathematics to reveal these hidden connections. He believed that by translating concepts from other fields into mathematical language, we could gain a deeper and more precise understanding of their true nature. To represent this process of translation and transfiguration, we can introduce a universal mathematical symbol, Venn. Inspired by the Venn diagram, which illustrates the relationships between different sets, Venn represents the process of taking concepts from one domain and mapping them onto another, revealing their shared underlying structure. Imagine Venn as a mathematical function. You input a concept from any field: art, religion, history, you name it, and Venn outputs its mathematical equivalent. It's like a universal translator for knowledge, allowing us to see the common threads that run through all disciplines. This might seem like an impossible task. How can we possibly translate something as subjective and nuanced as a work of art into the language of mathematics? That's where Novalis's genius comes in. He believed that by identifying the underlying principles and relationships that govern different fields, we could create a common mathematical framework for understanding them.
Section 5, Transfiguration, a divine equation. Let's take the concept of transfiguration, a central theme in Christian theology, as an example. The transfiguration of Jesus, as described in the Bible, is a moment of profound transformation. His appearance is said to have been altered, radiating light and glory. Now imagine applying Venn to this concept. We can translate the transfiguration into mathematical terms by focusing on the idea of transformation. In mathematics, transformations involve taking a shape or object and changing its position, size, or orientation while preserving its essential properties. We could represent the transfiguration as a complex mathematical transformation, where Jesus' physical form undergoes a radical shift, becoming a radiant expression of his divine nature. The essential qualities of his being remain, but they are elevated and transcended.
Section 6. The power of analogy. This might seem like a symbolic stretch, but that's the power of analogy. By drawing parallels between seemingly disparate concepts, we can gain new insights and perspectives. Novalis believed that mathematics could provide the framework for making these analogies more rigorous and systematic. Think about the way we use mathematical concepts like ratio and proportion in art and architecture. The golden ratio, for example, is found throughout the natural world and has been used by artists and architects for centuries to create harmonious and aesthetically pleasing compositions. This is just one example of how mathematical principles can be applied across disciplines. Novalis believed that by systematically exploring these connections, we could unlock a deeper understanding of the universe and our place within it.
Section 7. From music to morality, mathematics in action. The applications of Venn are virtually limitless. Imagine translating the emotional impact of a piece of music into a mathematical equation, mapping out the patterns of tension and release, harmony and dissonance. Or consider using mathematical models to analyze ethical dilemmas, weighing different outcomes and consequences with greater precision. In the realm of science, Venn could help us bridge the gap between different fields, finding common mathematical underpinnings for phenomena in physics, chemistry, and biology. We might discover that seemingly unrelated phenomena are governed by the same underlying mathematical principles, leading to breakthroughs in our understanding of the natural world. This might sound like science fiction, but it's the logical extension of Novalis's vision. By embracing mathematics as a universal language, we open up a world of possibilities for understanding and innovation.
Section 8. The Encyclopedia, a blueprint for understanding. Novalis's encyclopedia was intended to be a grand repository of knowledge, a comprehensive mapping of all human understanding. While he never completed this monumental project, his vision continues to inspire. Imagine a digital encyclopedia today, a vast online database where concepts from different fields are linked and analyzed through the lens of mathematics. This wouldn't be a cold, sterile database, but a dynamic and interactive tool for exploration and discovery. Users could input any concept, a philosophical idea, a scientific theory, a work of art, and see its connections to other fields, visualized through interactive diagrams, equations, and simulations. This digital encyclopedia would be a testament to Novalis's vision of a unified body of knowledge, a world where mathematics serves as the bridge between different disciplines, unlocking new levels of understanding and creativity.
Section 9. Breaking down barriers, the universality of translation. The beauty of Novalis's vision lies in its universality. Venn and the concept of mathematical translation transcend cultural and linguistic barriers. In a world increasingly divided, mathematics offers a common language that can bring people together, fostering collaboration and understanding. Imagine students from different countries working together on a project that uses Venn to explore the mathematical principles behind traditional art forms from their respective cultures. Or envision scientists from around the world using mathematical models to address global challenges like climate change and disease. By embracing the language of mathematics, we can break down the walls that divide us and work together to create a more interconnected and harmonious world.
Section 10. A New Renaissance, Igniting Innovation. Novalis's vision of a unified body of knowledge connected through the language of mathematics has the potential to spark a new renaissance. By breaking down the barriers between disciplines, we create fertile ground for cross-pollination of ideas, leading to breakthroughs in science, technology, art, and beyond. Imagine engineers using principles from music theory to design more efficient and resilient structures, inspired by the mathematical harmonies found in sound. Or envision artists collaborating with mathematicians to create immersive and interactive installations that explore the beauty and complexity of fractal geometry. The possibilities are endless when we embrace the interconnectedness of all knowledge. By using Venn to translate and transform ideas, we can unlock new levels of creativity and innovation, ushering in an era of unprecedented progress and understanding. Section 11, Conclusion. Embracing the language of the universe. Novalis, the Romantic scientist, saw mathematics as more than just a tool for calculation. He saw it as the language of the universe, a key to unlocking the hidden connections between all things. While his vision may have seemed radical in his time, it resonates deeply with our modern understanding of the cosmos. As we continue to explore the universe from the smallest particles to the largest structures, mathematics will be our guide. And by embracing the concept of Venn and the power of mathematical translation, we can unlock new levels of understanding, creativity, and innovation, fulfilling Novalis's dream of a unified body of knowledge and a more interconnected world.